The argument is exactly the same. We just have the premises laid out here, but you see we have implications. The first rule to be able to apply resolution is, remember, you want the closed form, close, okay? You want all of the premises to be expressed as a clause. So what you need to do is, if you have anything other than ands, ors, etc., put them in and, or, etc. notation. So get rid of the implications. That's the key. So what you need to do is you just write this, the first premise as not T or M or E. Now you see this is in clause form. Even there are no ands, all literals and a disjunction. The second one, write that as not S or not E. Now the third one, here you have an and, okay? In a closed form, I don't want to see any ands. Remember, all premises are anded already. So if you see an and, break it into multiple premises. So write this as T and S as separate clauses, okay? So this is what you have in clause form, right? Now, to this, I'm going to apply resolution and see if I can reach to the conclusion M. How am I going to do that? I'm going to look for common literals in two premises where in one the literal appears as is and in the other I need to see its negation. Okay, so for instance here I have negation of t and here I have just t. So I resolve these two, okay, and the resolvent is m or e, right? The literal t disappears when I resolve these two. And then in the second step, I can resolve these two through the literal s. In one, I see just s. In the other, I see not s. So I resolve these and the s literals disappear. What is left is just not e. And then these e and not e. So I can resolve these two. And what remains is M, which was the intended conclusion all along. So this also shows the validity of the given argument, okay? So the good thing about resolution is, from our perspective, the first observation is that you don't need to memorize all those rules: simplification, addition, hypothetical syllogism, disjunctive syllogism, uh, modus ponens, modus tollens, etc. Okay, you just need to understand one rule, one resolution rule, and how to apply it. It makes it easier, and that's from our perspective on, let's say, pen and paper. And the second perspective and second advantage is that maybe if you follow this, you might have the idea that this can be made into a well-defined procedure, which we call an algorithm, right? We didn't discuss algorithms yet, but I trust probably all of you have an idea what an algorithm is. So the good thing about resolution is you can take all of these procedure and make it into an algorithm and in, um, implement it on a digital computer. So it makes this proof procedure uh, in a standard way. Okay. Now, at this point, I have to emphasize one thing. Yes, we have shown that from the premises, we were able to arrive at the intended uh, conclusion M, but usually this is not how we do it. Okay, we will come to that in a minute. Okay, so this is the procedure here. The first thing you need to do is put the premises in clause form. Okay. Now the second item here is what I was talking about just now. We usually do not start with only the premises and try to end up with the intended conclusion. What we do is we negate the conclusion, okay, and include that as a new premise, okay? So you now have a new set of premises And from this, you try to reach, or you try to see whether you can reach what we call the empty clause. Okay? So for instance, consider this very simple case, P and not P. Let's say you have these two premises. If you resolve them, you see you'll end up with an empty clause because the resolvent of these is just empty. However, what are these two premises together? It's just P and not P. It's simply a contradiction. So therefore, contradiction. So what does this mean? That means if you have an argument and if you add the negation of the conclusion as a new premise and you manage to end up with the empty clause, that means the premises are incompatible with the negation of the conclusion. Therefore, they, the original premises, must entail the original conclusion. So this is how we actually employ resolution in practice. We do not try to end up with the conclusion itself, but instead, because this simplifies the algorithm, because the result doesn't change with what you are trying to do, you just negate the conclusion, include it as a new premise, and then from this new set of premises, you try to end up with a contradiction, essentially. Okay, so let's again start with the same, and not T and T. These two premises are resolved into M or E, and then you resolve them together with this. Sorry, not that one, but these two, not S with S. These two clauses resolve into not E, and then you can resolve these two. E and not E appear, and the result is M. Now you see you have not M and M together, and then you can resolve them to obtain the empty clause, which means that the original proposition, the original argument was a valid argument.